Hello students, how are you all? So today we will have some special class about lens. So first of all, what is lens? That is actually made by any transparent material like glass or any kind of silicon transparent material. Okay, so lens, how does it actually work? So before that, let me discuss some idea or types of lens. That is, as you can see, there are three type of lenses. This one is biconvex. All you got the idea about concave and convex earlier. Right now concave means that which one have the cave, and convex means that which one is actually moving outward. So this is the concave and this one is the convex. So first of all we have biconvex, that means both side is the convex. So that is known as biconvex. After that, plano-convex, that means one side is having a plane side, another is convex. So plano-convex. And the last one is concavo-convex, that is quite look like a half moon, where this side is concave while the other side is convex. So that is why it is called concavo-convex. Similarly, we have three also other types for the convex lens. Okay. So you will get that in your next page. But how does it actually work? We know that biconvex is a converging lens. Why? Because whenever the biconvex lens is used, let me draw the idea about it first. So in this case, whenever we send the parallel rays, let me change the color of rays. Okay. So in this case, while we have the parallel rays coming along x-axis parallel to the optical axis, then they will meet at the focus after getting converged by this lens. So as we can see, by converging all this ray, we are getting a focus point, and that is why you are having this lens, that means biconvex lens, as a converging lens. Similarly, for biconcave lens, we know that that is completely a diverging lens. But what is the actual idea behind it? We know that when a light ray passes through a prism, then the deviation happens and it's bent a little bit downward. Similarly, if we put the prism invertly, then the same thing will happen, but this time the light will move a little bit upward. But coming to the parallel glass slab, we know that if a light passes normally to it, it will directly pass without any deviation. So as you can see, this biconvex lens is actually nothing but the construction of two prisms and one parallel glass slab. I gave you the idea very simply, but there are so many this kind of shapes, so many curvatures are there that is actually helping to converge the light rays very significantly. How we can determine that which one will be the focus and which one will be the parallel optical axis. So let me give you the idea behind it first. As you can see, this is a complete straight line along x-axis. So I'm just drawing a biconvex lens over here. Okay. So what is a convex lens? If it is not here, instead of this, we can draw two circles. Okay. Let me draw next one with another color. So as you can see, in between of that, we have this convex, actually the biconvex lens. So what exactly the idea we get from here? That is, biconvex lens is nothing but the part of two circles, while each of its plane having an arc of the one circle and another circle. Okay, so while we have two circles, there should be two centers. So what is the optical center? If you count or measure this C1 and C2 and then divide it into two equal parts, then you will have some point at the mid, and that will be your optical center over here. So by this condition we will have some optical center over here. Okay, now the points lies on this line is called optical axis. Also, what about the focus? We have two different focus over here, that is for the circle C2 we have F2 from here to here, and for C1 we have focus from here to here. So I hope the idea is clear about this and you got the idea about the focus, optical center, and also about the optical axis. Okay, so I have my own diagram over here that will help you to give the idea about the position of object with position of image. So the first one that I already dictate about, that is biconvex lens, is used as a converging lens. So while parallel rays fall on it, the all rays will converge at a certain point, and that point is known as focus. Okay, so if the rays are parallel but not parallel with the optical axis, then what will happen? Then the rays will also converge but not in focus. They will shift from the focus to a certain point, that is say f dash, but they will exactly stay at the top or at the bottom of the focus. So that means if we imagine a plane over there, so that is known as the focus plane, where the primary focus, that is the first case, primary focus, and in here the secondary focuses are also stays on. So I hope you got the idea about the light rays coming parallel to the optical axis converging at focus, I mean primary focus, and coming parallel to each other but not with optical axis is converging to the secondary focus. So that is all about the converging of rays. One more thing I would like to add over here, that the light rays are coming from infinity. Infinity means the possible, the highest distance. So while the rays are coming from infinity, they are considering as parallel to each other. Also from sun, the light coming from sun also considered as parallel to each other. That as the distance between the earth and the sun is very high. There are few portions, that is from the optical center to the focus, then double of focus, then after that up to infinite. That means the extreme possible distance. So if you put the object between 2f and the infinite, then the image will be inverted and it will be at the other side between f to 2f. So we have over here the second case, that is the object is right now at 2f. So the image will be also at 2f. But this time the image also will be inverted. You can see the possible ray diagram, that is how it is happening over there. If you put that object at focus, what will happen? We already learned that if the light rays coming from infinity is fall on the lens, it will be get converged at focus. If object right now at focus, then you can see that the image will be at infinite. So right now the final condition, that if the object placed between the optical center or the surface of lens and to the focus, then where the image will be formed. Then the image will be formed at a certain distance, but this time the image will be counted as a virtual one, because as you can see that the dotted ray diagram is giving you the idea of image. You are not finding the image over here. So that means the image will be virtual, erect, and magnified. Okay, so in this part we will learn about the sine rule. That is very simple. Whenever we have a certain biconvex lens over here, as I'm drawing over here, that if you place certain object over here, always the light comes from this. So we got the direction of light, and we are assuming that this direction of light is positive. So as you can see, I'm also taking with Cartesian coordinate. That means this is positive x-axis. Let me draw it. This is positive x-axis. This is negative x-axis. this is y, and this is negative y. So remember, whenever you will measure something, that will be always start from pole. So if you trying to measure the object distance, that means you have to start from this pole. So while you are moving, that means you are moving along negative x-axis. So the value of u is actually negative. That means the object distance in this case is negative. Acha. Coming to image, if the image is inverted and over here, also we need to find the measurement from the pole to that image. So as you can see, this time say it is v, and as we are moving along positive x direction and also with the direction of light, so it is positive. So that is all about position along x axis. Coming to position along y-axis. So only the thing that is depends upon y-axis, that is the height of image and height of object. So as you can see, this is along positive y-axis. So if the height of image will be HO, that will be positive. So whenever the image, sorry, that was for object, and right now if we talk about the height of image, that is along negative x-axis, because this time the image is inverted. So all we can say, that value will come in negative. So this is all about the idea of sine rule, and after applying all this sine rule, we will have the length formula, that is 1 by v minus 1 by u equal to 1 by l. So that is length formula, very important one. And also one more thing I want to dictate over here, that is the magnification and the power of the lens. Alright, so let me discuss the magnification first. So what is magnification? Magnification is how much the image right now comparing to your object. So that means you need to compare their height. So the ratio of the height of image to the height of object is known as magnification. And for that, if you do the similarity formula, or if you use the similarity proof according to your book, then you will get that hi by ho is equal to v by u, where v is the image distance and u is the object distance. So this is how you will find the magnification. Okay, so two formulas are very important over here, that is the lens formula and the magnification formula. All are sums coming from these two, and one more formula is over there, that is the power. So if you want to measure the power of lens, that means that is nothing but the reciprocal of the focus. So all you have to do, first of all, you have to find the focus of that lens and just make it reciprocal, you will have the power of that lens. So that's it for today. If you have any more doubt, you can ask me anytime. I will surely try to help you. Till then, thank you for watching. Best of luck for your exam.